Hey guys, so today we're going to talk about Chapter 10, Section 3, which is area of regular polygons. Uh, here we're going to have a little bit of vocabulary. The first thing that this section shows you is that we have this polygon. So this polygon has 1, 2, 3, 4, 5, 6 sides. So this is a hexagon. Hexagon has 6 sides. And this hexagon is inside of this circle. And when we say that something is inside a circle, we say that it's circumscribed. Uh, when we say the word circumscribed, it means that it's inside the circle, but it's also inside the circle such that the vertices of the polygon touches the end of the circle. So if you notice, the vertices are the points or the corners. It's a hexagon. It has 6 sides and also has 1, 2, 3, 4, 5, 6 corners. Those 6 corners touch the edge of the circle. Those 6 corners touch the edge of the circle. So we have the corner over here and it touches the edge of the circle. Well, just like this, since the hexagon is inscribed in the circle has a center. The hexagon has a center. The center is for the hexagon and the center for the circle are the same thing. So the center applies to the regular hexagon. The center applies to the circle. When we have the center of the circle go out to the corner, and that same corner is also the edge of the circle, we call that the radius. So in this case, the blue dashed lines here in this figure is our radius. Then we have something called the apothem. We've already heard center, we've already heard radius. The new thing that we might not have heard before is called the apothem. And the apothem is the distance from the center of the circle to the side of the polygon. So I'm going to break up this hexagon as best I can. So I cut the hexagon in half. This is my radius from the center of this hexagon, or this half of this hexagon, to the corner. Remember that these corners is also touching our inscribed circle. So this would be our center in the middle. So that's our center. This would be our radius. And this other line is going to come from the center of the circle right in the middle of the side. This is cutting this side in half. It's also going to form a 90-degree angle. It's also going to form a 90-degree angle. It's going to be perpendicular to the side. So it comes from the center circle and it's perpendicular to the side. That is called the apothem. That is the apothem. So we have the radius. So we have the apothem. The apothem comes down from the center, forms a perpendicular intersection with the side. This is our side right here. Things about this apothem. There's going to be an angle associated with the center, and the apothem cuts this angle in half. This angle here is going to be cut in half. In addition to that, this side, this perpendicular side, is also going to be cut in half. So the angle can be cut in half, and the side is going to be cut in half, which makes this a perpendicular bisector by definition. So the apothem, in the case of this, is the perpendicular bisector. Also note, if we look back at our original picture, we have a hexagon which is 6 sides, And when we cut up our hexagon with our two radii, here's a radius, together we call them radii, it forms a triangle, right? So since we have a hexagon which is 6 sides, we also have 1, 2, 3, 4, 5, 6 triangles. We have 6 triangles. In addition to having 6 triangles, these triangles are also congruent. These triangles are also congruent. They are the same. And we're going to find out in a little bit why that's important in us finding the area of these figures. These figures are called regular polygons. Regular means they have the same shape and size. Well, more specifically, they have the same sides. All the sides are going to be the same. The sides around this polygon. They also have the same angles. So we have regular polygons that they have the same sides. They're all congruent, and they all have the same angles. They're all congruent angles. Congruent sides, congruent angles makes these regular polygons. And this particular section is going to deal with the areas of regular polygons. Okay, so the first example that the book gives is that we have this regular. In this case, it has 1, 2, 3, 4, 5 sides. So this is a regular pentagon. And we have a bunch of angles, right? I'm going to break it up for a second into a triangle. So I'm going to expand on this pentagon. I'm just going to draw a triangle, just a simple, horrible drawn triangle. This would be our radii. So the side of the triangle would be our radius. There's going to be 2 of them. Then we have our apothem that comes down the middle and cuts everything in half. And we have a bunch of angles. The first angle is angle 1. So this whole entire thing, I'm going to make it black. So this whole entire thing is angle 1. Then we have angle 2. And angle 2 is half of angle 1. It's going to cut this angle in half. Where the apothem cuts this angle 1 is going to be cut in half. So in the case of angle 2, we're going to say that angle 2 is going to be half of that. Then we have angle 3. And this over here would be angle 3. So let's first start off with angle 1. In order for us to find angle 1, notice that the angle 1 is here, 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 and here, so it's around the circle. And since it's a pentagon, we have 5 triangles, and we have 5 what they call a central angle. This is the angle associated with the center of the polygon, in this case the center of the pentagon, the regular pentagon. So we call this the central angle, and there's 5 of them. Since there's 5 of them, and it goes around the center, we can think of going around as a circle, and we all know that the degrees of a circle there's 1r in degree. Degree of a circle is 360 degrees. 360 degrees. So in order for us to find what the central angle is, we're going to divide the degrees of a circle and divide it by the number of central angles. So we have 5 triangles, which means we have 5 central angles because it's a pentagon. We divide it by 5. So in order to find angle 1, we divide 360 degrees by 5. And that gives us 72 degrees. So angle 1 is 72 degrees. To find angle 2, remember the apothem cuts the central angle in half. So the central angle is being cut in half, which is angle 1. So since the apothem cuts the central angle in half, we can say that angle 2 is going to be half of angle 1. So in this case, it's going to be half of 72 degrees, which means that angle 2 is 36 degrees. Then we have angle 3. And the way that we get angle 3 is that if you notice, angle 2, this apothem cuts this triangle into 2 smaller triangles. Angle 2 is one of the triangles. Since it's a perpendicular intersection, we also have another angle in this small triangle, which is 90 degrees. So we have angle 2, we have plus 90 degrees, and then we can find our angle 3 because we know that the 3 angles inside of a triangle equals up to 180. So angle 3 is going to be equal to 180, because that's the number of degrees in a triangle, minus angle 2, minus 90 degrees. Again, angle 2 is inside this triangle, angle 3 is part of this triangle, and the 90 degrees is part of this triangle. So angle 2 plus 90 plus angle 3 gives me 180. So I can say that 180 minus angle 2 minus 90, which would be 180 minus 36 minus 90. So we can say that angle 3 is 54 degrees. And if you want to check yourself, all you have to do is add the 3 angles, 72 plus 36 plus 54, and they should give you 36 plus 54 plus 90. If you add those 3 together, they should give you 180. And that's how you find the 3 angles. So in the case of this one, they got it. They say that at we have a right octagon, and they have the picture drawn there. They want you to find angle 1, 2, and 3. So since we have a regular octagon, an octagon has 8 sides. So in order for us to find the central angle, angle 1, we're going to divide 360 degrees divided by 8 sides, which gives us our central angle, or angle 1. So 360 divided by 8, our central angle, or angle 1, is 45 degrees. And then our angle 2 Remember, angle 2 is 1/2. Since the apothem cuts the angle in half, the central angle in half. 1/2 of angle 1, which means that it's going to be 1/2 of 45, which means that our angle 2 is going to be 22.5 degrees. Then we have our angle 3, and remember that angle 2 plus angle 3 plus this 90-degree angle here forms this little triangle here. So to find angle 3, all I have to do is subtract 180 minus angle 2 minus 90 degrees. So it's going to be 180 minus 22.5 minus 90 degrees, which gives me 67.5 degrees. It all stems from the information knowing that I have a regular octagon, which means I have 8 sides or 8 triangles or 8 central angles. Initially, again, to get angle 1, I divided 360 by 8, which gave me 45. I know that angle 2 is the apothem cuts angle 1 in half. So I know that angle 2 is half of angle 1, so 45 divided by 2, which gives me 22.5. And then I know that angle 2 plus angle 3 plus the 90 degrees gives me 180, which is the measurement of a triangle. So I subtract angle 2 and 90 from 180, which gives me angle 3, which is 67.5. Okay. Remember I said earlier that all of these triangles are the same. They're all congruent because they're regular polygons. I divided the central angle by 3, which gives me the center angle, which is all the way around. All of these triangles, these radii are the same. These sides are the same. We have an apothem. We have an apothem. The side S is for side, and this side is also the base. So if you recall, an area of a triangle is 1/2 the base times the height. Well, when we talk about area of a triangle in a regular polygon, the base is now the apothem, A for the apothem, and H is now the side of the polygon. So this is apothem, and this is now the side of the polygon, whatever the regular polygon is. Side of the regular polygon. Alright, it's still a triangle. It still works. So when we do the area of the triangle of a regular polygon, we go 1/2 A times side. But we're not done. This only gives me one triangle in the regular polygon. Well, that's not enough. I need the whole entire polygon. So since this only gives me one triangle of the regular polygon, I have to do an additional step. And that additional step is to find out the number of sides that I'm dealing with in a regular polygon. So if we have area of one triangle equal to 1/2 the apothem times the side of one side, I have to multiply the number of triangles by the number of sides. So I have to multiply it by an additional thing, and that's n. And n is the number of sides. The number of sides that we're dealing with. So if we have a pentagon, it's 5 sides, n would be 5. If we have an octagon, that's 8 sides, it would be 8. N would be 8. If we had a decagon, that'd be 10 sides, n would be 10. So the number of sides times the one triangle, meaning 8 triangles, 9 triangles, 5 triangles, if we're dealing with octagon, uh, nonagon, and pentagon respectively, n would be the number of triangles, actually, number of sides, or number of triangles. They're really the same thing. Okay. But let's look at this s times n, right? Number of sides times n. That's really the perimeter. And it's the perimeter of the regular polygon. S times n is the perimeter. And we call that perimeter P. So P equals S times n. So our final equation, and the equation that the book gives, is that in order for us to find the area of a regular polygon, the area of a regular polygon is 1/2 the apothem times the perimeter, where the perimeter is the number of sides times the side itself of one triangle. This is the area of a regular polygon. 1/2 the apothem times the perimeter. And they gave you that right there, 1/2 A times P. So, with that information in mind, they give me an example to find the perimeter of this decagon, so it's 10. Oh, I can't read that. So they give me that the side is 10 because we have 10 sides, and the length of the side of the decagon is 10. So the side of the perimeter is equal to the number of sides times the side itself. In the case of this, since it's a decagon, we have 10 sides, and the length of the side, and the side is going to be, so here's our triangle. We have a 10 here, and we have this apothem, which I can't read just yet. What is the apothem? 12.3? Okay. So the apothem is 12.3. So since I know it's, actually, no, this is 8. Sorry. The side is 8, the apothem is 12.3, and it's a decagon, so we have 10 sides. So 10 sides times 8, our perimeter is 80 degrees. We know that the area of a regular polygon is 1/2 the apothem times the perimeter. So the apothem in this case is 12.3, and it's 12.3 times 80, and the book says, well, 12.3 times 80 is 492 It's 4092 square units. Because I don't think they give us the units. Oh no, they do. They give us inches. So 492 inches squared. So the first thing we're going to do is we're going to get the perimeter. We get the perimeter by multiplying the side, which is 8, times the number of sides. Since it's a decagon, we know that it's 10 sides. So it's going to be 10 times 8, which gives me 80. That's my perimeter. Then we plug that perimeter into our area of a regular polygon equation, 1/2 apothem times perimeter, or 1/2 A times P. They give us that the apothem is 12.3 from our drawing here. So the apothem is 12.3. And we plug that into there. So it's going to be 1/2 12.3 times 80, which gave us an area of 492 inches squared. Okay, so the problem that they give us here is we have a regular pentagon rather, with a 8 centimeter apothem and 11.6 centimeter sides. Since it's a pentagon, I know that the number of sides is 5. We have our triangle, which is one of the triangles of the pentagon. We have an apothem. Remember, it's going to form a 90-degree angle. Our apothem is 8 centimeters, and our side is 11.6 centimeters. So we have a side of 11.6. So I know that in order to find the perimeter, it's going to be n times the number of sides. So it's going to be, since it's a pentagon, I know that it's 5. So it's going to be 5 times 11.6, which means we have a perimeter of 58. Alright, we also know that area of a regular polygon is 1/2 the apothem times P. In this case, the apothem is equal to 8. So it's going to be 1/2 8 times 58. And that's going to be 232. So our area is 232 centimeters squared. Remember that with area, your units are always squared. Okay, so they tell me it was a pentagon. I know a pentagon has 5 sides, and I know that the side is equal to 11.6. So to find the perimeter, I multiply 5 times 11.6, which gives me P. Which is P, which is 58 inches, centimeters. And then I also know that the area of a regular polygon is 1/2 the apothem times P. They tell me that the apothem is 8, so it's going to be 1/2 8 times 58, or 232 centimeters squared. The second question it has here is, if the regular polygon is reduced in half, how does the perimeter of polygon change? Alright, so if our perimeter is equal to n times s, and they're telling me that the side is reduced by 1/2, that means that our perimeter is also reduced by 1/2. So our perimeter, we call this perimeter number 2, would be 1/2 times ns, or we can say that perimeter 2 would be 1/2 of P1, the first perimeter. So if we cut the side in half, we cut the perimeter in half. Okay. Alright, so remember, like I said in the previous section 10.2, we're going to do a lot of 30, 60, 90 triangles. We're going to do a lot of 45, 45, 90 triangles. So to refresh your memory, again, about a 30, 60, 90 if we have a 30, 60, 90 triangle, so 30, 60, 90 triangle, I know that the hypotenuse, I'm going to call it y. Remember, the hypotenuse is opposite of the 90 degree. This is 30 degrees, and this, I'm sorry, this is, yeah, 30 degrees, and this would be 60 degrees in the case of this. This is the shorter leg, right? This is the hypotenuse, and this is the longer leg. I don't know why I write 4. Okay. The hypotenuse is going to be equal to the shorter leg times 2, and the longer leg is going to be equal to the shorter leg times the square root of 3. That's our 30, 60, 90. We're going to see 30, 60, 90 triangles all the time when the regular polygon is A. And you might want to write this down in your notes. Hexagon. When we have a hexagon, a regular hexagon, we are going to have 30, 60, 90 triangles. We are going to have 30, 60, 90 triangles when we have a regular hexagon. Put it down, put it in your brain cells, memorize it. It's going to help you with a lot of these problems, because when you get tested on this, you're going to see, I can guarantee you're going to see at least one 30, 60, 90 or one 45, 45, 90. So if I were you, I would put that down into my mental Rolodex, if you guys even know what a Rolodex is, and say that when you have a regular hexagon, you're going to have a 30, 60, 90 triangle. So the example that they give here is a regular hexagon. In order for me to find, they give me, here's what they do. In order for me to find the central angle, right, I divide 360 divided by 6. That gives me 60. So my central angle is 60. So I'm going to blow up the triangle that they have. The center angle is 60 degrees. So when I draw my apothem, the apothem cuts everything in half, right? The apothem cuts everything in half. So now this 60 is being cut in half. I have a 30 degree triangle, a 30 degree angle inside the initial triangle. So this is 30 degrees, this would be 60 degrees, and then this would be 90 degrees. So I have a 30, 60, 90. Notice that they give me this between this here is 1.5. This 1.5 pertains to half of the side, because remember the apothem cuts this in half, and the apothem cuts the angle in half. That's why I say this is 30, because the angle is cut in half. This 1.5 represents half of the side. So if I have 1.5 as half of the side, then I know that the entire side is equal to 1.5 times 2. So the entire side is 3. The side is 3. I also know from my 30, 60, 90 triangle that this 1.5 is the shorter leg. 1.5 is the shorter leg of my 30, 60, 90. The apothem in this case will be the longer leg of this 30, 60, 90. The apothem will be the longer leg of the 30, 60, 90, and I know that the longer leg is equal to the shorter leg times the square root of 3. So the apothem, which is the longer leg, is going to be equal to 1.5 times the square root of 3. 1.5 times the square root of 3. I also know that I'm dealing with a hexagon, so I know that the perimeter is going to be equal to the number of sides times the side itself. Well, I know that the side is 3. And I know that this is a hexagon, so I know that there's 6 sides. So it's going to be 6 times 3, which gives me 18. So the perimeter is 18. The apothem is 1.5 times the square root of 3. And that's enough information to find the area of the regular polygon. Remember that the area of a regular polygon is the apothem times the perimeter times 1/2. We have the apothem as 1.5 times the square root of 3. And we're going to multiply that times 18. 18 is my perimeter. My apothem is 1.5 square root of 3, and I'm dividing that by 2. And that gives me a perimeter, and they want to round it to the nearest millimeter squared, is 23.38. So 23 millimeters squared. 23 millimeters squared. So first thing I do is I recognize that I have a regular hexagon, which means I'm dealing with a 30, 60, 90 triangle. I realize that they give me the 1.5, which is the shorter leg of this 30, 60, 90. So I know that the shorter leg is equal to, or the longer leg is equal to the shorter leg times the square root of 3. And that longer leg is also the apothem of this triangle. So the apothem is equal to 1.5 times the square root of 3. I know that that 1.5 is also half of the whole side of the triangle, so I know that if I multiply that by 2, 1.5 times 2, I'll get the side of the triangle, which is 3. The perimeter is the number of sides times 3, and the number of sides is 6 since it's a hexagon. 6 times 3, which gives me the perimeter of 18. So in order for me to find the area, I multiply the apothem times the perimeter times 1/2, which gave me 23 millimeters squared. So the example that the book gives, they say the side of a regular hexagon of 16 feet. What is the area of the hexagon? Rounded to the nearest square feet. So we have a regular hexagon. So a hexagon has 6 sides, so I know that n equals 6. I'm going to draw my triangle. Since it's a hexagon, I know I'm dealing with a 30, 60, 90. So I know that that's 30 degrees, and I know that this is 90, and I know that that's 60. They tell me that the whole entire side is 16. So I can already find my perimeter. Perimeter is equal to the number of sides times the side itself, which is 6 times 16. So my perimeter is going to be 96. Alright, so we have the perimeter. Since they tell me that the whole entire side is 16, I can find the shorter leg by dividing 16 by 2. So this is going to be 8. So this here is 8. Since this is a 30, 60, 90, I can find a longer leg, which is also my apothem. By multiplying 8 times the square root of 3. Because the shorter leg is equal to, the longer leg is equal to the shorter leg times the square root of 3. So the apothem is 8 times the square root of 3. So I have my perimeter, I have my apothem, so I know that the area of this regular polygon is 1/2 the apothem times the perimeter, which is 1/2 of 8 times the square root of 3 times 96. Which gives me 384 times the square root of 3, which is approximately 665. They want it rounded to the nearest square foot. 665 feet squared. So first thing you do is find the perimeter. You know that it's a 360/90, so they'll usually give you the shorter leg. Either you have to divide the whole side by 2 to find the shorter leg, or they give you the shorter leg. You're going to multiply that shorter leg times the square root of 3, because that gives you the longer leg, and that longer leg is also the apothem. So after you find the perimeter and the apothem, you multiply them, divide them by 2, and that gets you your area, which in this case is 665 feet squared. Alright. We have four examples. So I'm going to do all these 4 and then I'll end it. They give us for number 1 a regular quadrilateral, or with 90 degrees, so we'll call that a square. They give us the apothem as 5. So in order to find the central angle, since I know I'm dealing with a square, I'm going to divide 360 divided by 4. 360 divided by 4. And that gives me 90. So 90 is my central angle. But I know, so if I was to draw the triangle out, if I have this apothem here, and my apothem is 5, I know that this 90 is being cut in half. So this is now 45 because I'm dividing it by 2. I'm going to divide this 90 degrees by 2 to give me 45 degrees. So guess what I'm dealing with? I'm dealing with a 45, 45, 90. So that's 45, that's 45, and this is 90. Which means that this is an isosceles triangle, so that means that the apothem in this case is equal to that guy over there. So if the apothem is 5, then the side is 5. So my apothem is 5, and half of the side is also 5. So I'll call it half the side. Half the side is also 5. But I want the whole side, so I will multiply that by 2. So I know that the side of my triangle is 10. So this whole thing here is 10. I know that the perimeter is equal to the number of sides times the side. So my side is 10, and since it's a square, I know it has 4 sides. So it's 4 times 5. So my perimeter is 20. I also know that the area of a regular polygon is 1/2 the apothem times the perimeter. In this case, it's going to be 1/2 of 5 times 20, which is 50. So the perimeter is 50, and it's going to be 50. Oh, because I don't know how to multiply. Not 4 times 5, but 4 times 10. That makes a big difference. So that's 40. My mistake. That's a big mistake. Alright, that makes more sense. So 100. 100 inches squared. My mistake. Okay. I confused the side with the apothem. Alright. And that is the area of the regular triangle. Okay. We have for number 2, 1, 2, 3, 4, 5. This is a hexagon. We were given that the side is 3. We know that since it's a hexagon, the number of sides is 6. So that I know that the perimeter is equal to the number of sides times the side. So in this case, it's 3 times 6. So my perimeter is 18. So we found the perimeter. I'm going to draw it as a triangle. Let's do it like this. Actually, no, I had it right the first time. Let's do this. This is not to scale. So I know that this is a hexagon, right? So I know I'm dealing with a 30, 60, 90. So if I draw my apothem, since this is 3, I know that this guy here is 1.5 because it's half of this. This apothem cuts everything in half. So that's 1.5. That's my shorter leg, right? And I know that the longer leg on a 30, 60, 90 is equal to the apothem. So I know that the longer leg is equal to the shorter leg times the square root of 3. So in this case, the apothem is equal to 1.5 times the square root of 3. And that's enough. So then I know that the area of a regular polygon is 1/2 the apothem times the perimeter, which 1/2 of 1.5 times the square root of 3 times 18. And that gives me, and they want it rounded as to the nearest tenth, that gives me 23.38, which is 23.4 feet squared. Yeah, this is all because I know I was dealing with a hexagon, which is a 30, 60, 90. Alright, for number 3,